So last week I told Jesse that there was some stuff in Swift 4 that solved some problems that I had, and I'd present on that. And he said, don't injure yourself at basketball, because probably 3 times in the past I've offered to present and injured myself the week before. This time I injured myself 6 weeks ago, so I can wiggle my fingers again. So that's all right. But when I came to look at it, the problems that I had, I couldn't work out. I couldn't reproduce them, and I couldn't work out how Swift 4 solved them. So I don't really have that much to present on that side. But the main thing I wanted to see was around protocols that have an associated type, and then you can't pass it around as a protocol anymore. It can only be a type constraint because it doesn't know what the associated type is. And I thought that was in Swift 4, but it sounds like it got bumped. I can't find any reference of it being in Swift 4.
I don't think it's anything that you're looking at. There's a lot of performance versus different things, but I assume you're going to talk about type ratio, right?
Going to talk about?
Type ratio.
No, I'm not going to talk about type ratio. I just wanted to show like a couple of little simple things that I also hit that are solved in Swift 4. So a little while ago, we were mucking around with this problem of like pulling strongly typed values out of a kind of weakly typed systems. That could be like the JSON stuff that you're getting back, but Codable solves a lot of that. So we're looking at pulling stuff out of the info dictionary and the bundle, and how could we come up with a way that, just a really easy way of just specifying in one place what those keys are and mapping them. And I guess when we say strongly typed, there's still one place where we're mapping to a magic string, but hopefully we only have to do it once. So we had this idea that we would essentially wrap the info dictionary and then provide the keys that we want to access out of them. And then we would essentially provide a way of automatically extending by NS bundle now to return that type, so we could interact with it in a strongly typed way rather than just mapping in keys and having to worry about this kind of string to any and not really knowing what you're going to get back. So that was the problem we were playing with. And we'd like to interact with it with a subscript. So it'd be really nice to just have a little subscript extension and say, let's just access it by the key, and it'll pull out the value that we want. Of course, we have tests for this. That's the way we roll. Do they run and pass? Yes. Okay. The test pass, which is if the value doesn't exist, it gives you nil. If the value does exist, it pulls it out. But we have to do this cast to a string. And usually when you're pulling out strongly typed values, we're mapping them into data. Like if you look at the Codable stuff, you have a strongly typed model that you're binding into. So you already know the types of the things you're pulling out. And so it'd be really nice not to have to cast that value to match them up. It should be able to do that for you. And so, yeah, it'd be really nice to say, well, it already knows that it's going to return a string. So could we actually just get it to infer that and do it for you? So that's easy enough to do. We just say on the subscript, we say we'll give it a generic type T, and instead of returning any, let's return a T, and we'll cast the value to T.
Does it still need to be optional?
It still needs to be optional at this stage because I guess the value you pull out of a dictionary could be nil or anything, and it could also be the wrong type. So at this stage, it still needs to be optional. And this is the problem we hit, which Swift 4 solves. Of like the 10 problems I had that I thought Swift 4 solved, this was the easiest one to reproduce and show. And that's that you can't do generic types on Subscript in Swift 3. So let's pull that out, load up the latest and greatest. I was going to do this on my MacBook. I'm so glad I didn't now because it takes about 15 minutes to compile even like Hello World. So let's pull this out now. It's probably going to complain and says we can actually now bump it up to Swift 4. And now, does it compile now? It's getting confused because my tests were already compiled with Swift 3 and Swift 4, standard procedure, delete derived data. Start again. All right, and so this is actually just a problem in our test now where we were pulling this stuff out and casting it, but we actually already know what the type is that's coming back now. Did that compile or run? I haven't got glasses on, it's all blurry. So I can't type and I can't read. I'm like a grey programmer. Depressingly, team productivity is up without me being able to type. So I don't really know what that says. So let's say we want to pull an int value out. It says name. That should actually be build. And pull it out as... All right, so it doesn't cast to int very well. So our implementation... So partly, that's one thing I want to touch on is that obviously you can put generic types on the subscripts now, which is kind of handy. You couldn't do that before. In Swift 3...
Go up for a sec, Stu.
What was that?
Go up for a sec.
Go up for a sec.
So this is a string though, right?
Yes. So it actually is a string, and that value usually in your info dictionary, like in your bundle, is it is a string. Almost everything in that is a string. So what we need is not just a cast to a string. We actually need to convert it.
Yeah.
And so we might go and say, what we want is t, but we want t to be this convertible type, kind of like codable. And then we can return that. What is value here? An optional any. Let's just convert that to a string. Let's just say everything is a string in here, because I can't remember the rest of my demo. That's optional now. We can flat map it. Tom will love that.
You would have needed a question mark after value to get code completion.
Yes, we will. But because we're all functional now, we'll flat map it instead.
Let's flat map that shit.
Flat map it. That's basically the solution. If you can't work out what's happening, you're trying to map something that nothing's working, flat map it.
And wait CPU cycle. Yep.
Yep, cool. So if you want to see, like this is just that convertible thing is just an easy way of converting between values. So if you want to see that, there's just a couple of little protocols there, but it's just a way of converting into a different type. And Matt mentioned whether we don't want it to be optional, right? Like, to be honest, I'd rather not crash things. I don't want to unwrap it in a different way. I'd rather just fall back to some different things. So let's say we want that just to be t. And so let's say in these tests, there is no nil case if we always return a value. But if it's a string, we want to return the string. If it's an int, we want to return an int. And actually, this case does exist, but it's not nil. Let's say it's empty string. Like if this is a string and it doesn't match, we'll give it a default value. All right. That doesn't work because we haven't unwrapped it. So let's say it's convertible and defaulting. So that's another little protocol that will give it a default value. And so we can say if it doesn't come out of any of that, whatever the type is, give me the default value for what that type is. And again, that's just another little protocol that can give you default values for the different types. And so, let's run our tests again.
Is there a good list of those default values?
I mean, I define them, so you can choose what they are. It's saying blah, blah, blah is not unwrapped, something, something. Have I done something really stupid? That seems like it should be doing the right thing. Is it that it wants these to be optional? Oh, it built. They shouldn't have to be optional, so I don't know why that is.
What is speak bundle?
So the other thing I did, which I probably didn't touch on, is if we want to be able to, if there's a bunch of things in your code that depend on values out of the bundle, I want to be able to unit test everything in the app. So if there's things that depend on the info dictionary, I want a way to test that. So we basically say in this case, all we care about from the bundle is the info dictionary. We define that as a protocol. The real bundle obviously already implements that type for us, but it just means that in our tests we can say, let's just create fake bundles that essentially imitate real production. So, yeah, just being able to inject it, and then we can inject that dependency into anything that depends on the bundle. We don't do that in that many cases for the bundle, but we certainly do that thing of defining a protocol and injecting stub implementations pretty often to make things testable. Which is annoying if you have generic types on them because you can't inject the protocol anymore. That was my original problem. Did anyone see it run while we're talking? Did it run?
They're green.
They're green. Okay. So the second bit that I thought was Swift 4 is this thing that you can now define a type as like it's a protocol and a something else protocol. Doing it in a generic type constraint like this apparently happened in Swift 3, so I just missed out on that. So we can do that bit already. The bit that they've added, I guess, is being able to define that as a variable type. So
you can do a class, so you can go to your ID controller and like convertible and default or something.
Yeah, so you can say something now, and if we had a thing here, we could say that is convertible and defaulting. I think that is the new bit in Swift 4.
I think that exists. I think what you can do now is you should put a class in front, like you can controller as well. I can think off the top of my head.
Ah, right, yeah.
And then it'll batch all of those versus before when it didn't.
Gotcha. So doing it with other types. Anyway, so I was a little bit behind the ball. I thought this syntax, because you can do it with the where clauses obviously, and it does the same thing, but it takes up the whole screen. So that's a nice little concise syntax for doing like it's convertible and you can get default values out of it. But turns out it was in Swift 3 already. So
Convertible is actually that with encoding and decoding.
yeah. So I learned something from putting together this little demo that already existed for over a year, and I just didn't know about it. But the generic type constraint I think is actually really useful, and that really nice syntax of being able to do subscript into it. The more you build higher level models, I think that's a really nice way of interacting with your models. So being able to do that is, really useful. Anyway, that was just a little bit into the actual bits of Swift 4 that I found useful, and I can't reproduce their other problems. So yeah, thanks for sticking around.